Unreal Engine is based on a class hierarchy. As we've seen, the actor class is capable of some very important things. Actors can be placed in a level. We've seen that we can spawn actors at runtime, and that actors can have components. Actors have useful functions like getActorLocation and getActorForwardVector. We've also seen that components are capable of some useful things on their own. Components can be added to actors. Components are based on the actor component class. We've seen that each actor has at least one component. This is the root component. By default, a newly created actor has a scene component for its root. The scene component class is a child of the actor component class. It has no mesh or any visual representation, but it does have a transform, meaning a location, rotation, and scale. It also supports attachment, meaning a scene component can be attached to other scene components. But we saw that we could add new components and attach them to the scene root, or even replace the scene root with a component with more capabilities, such as a static mesh component, which has a mesh that we can see in the level. The static mesh component class itself is a child class of the scene component class. So it inherits the ability to be attached and to have other components attached to it. This is why the static mesh component supports attachment. It is a scene component. So each class has its own properties and functionality that determine what can be done with it. But let's talk about the first sentence spoken in this video. Unreal Engine is based on a class hierarchy. This means that any given class will inherit variables and functionality from its parent classes. The actor class has its own set of properties, and we've seen that if we make a new blueprint class based on the actor class, that our new blueprint class has those properties too. We say that our new blueprint class is a child of the actor class, and that it inherits those properties from the actor class. The actor class has a parent class of its own, the object class. The object class is a parent class to the actor class, and the object class is much more basic than the actor. But those basic capabilities on the object class are inherited by the actor class, because the actor class is a child of the object class. So there exists a hierarchy of classes, and as we go down the hierarchy, classes get more and more capabilities. Let's take a look at the components we've used thus far. We've seen that scene components are fairly basic. They don't have a mesh or any visual representation, but they do support attachment. The static mesh component class is actually a child of the scene component class. The reason we can attach static mesh components to other components and attach other components to static mesh components is because the static mesh component class inherits this functionality from the scene component class. This is a simplification of the hierarchy, as there exist other classes in it as well. For instance, there exists other classes between the scene component and the static mesh component class in this hierarchy, such as the primitive component. The primitive component is a child class of scene component, and static mesh component is actually a child of primitive component. When we access the onComponentBeginOverlap delegate from one of our components, this is a property that exists on the primitive component class. This means that scene components don't have this property, but static mesh components do. The sphere overlap volume that we added to our small sphere actors is a child of the primitive component class as well, and that's why it has an onComponentBeginOverlap delegate property, because it inherits this from the primitive component class. If you keep going up the Unreal Engine hierarchy, you'll reach the object class, which is very near to the top. Actor is an indirect descendant of object, and so are these component classes: scene component, primitive component, static mesh component, sphere components. Object is thought of as a common ancestor to all these classes, and therefore we say that an instance of any one of these is an object. So it's important to understand that the capabilities of any given object in the game depend on its class and what classes that class is derived from. Now, we've mentioned before that a pawn is an actor, but an actor is not a pawn. In programming, we often refer to is a versus has a relationships. Think of it this way. A German Shepherd is a dog, and a dog is a mammal, which is a type of animal. The hierarchy goes animal, then mammal, then dog, then German Shepherd. Each time we go down one level in the hierarchy, we get more specific. A mammal is a type of animal, but not all animals are mammals. Some animals are reptiles, which are not mammals, right? Mammals and reptiles are children of the animal class, so they inherit properties that all animals have. Dog is more specific than mammal. A dog is a mammal, but not all mammals are dogs. There are cats, horses, ferrets, etc. So all dogs are mammals, but not all mammals are dogs. We can say that dog is a child of the mammal class. See how this relationship is one way? All mammals, reptiles, dogs, and German shepherds are descendants of the animal class. And we can indeed say that an instance of any of these classes is an animal. So we know in Unreal Engine that all of the classes we've used thus far are descendants of the object class. Object has the ability to store data. It has the ability to have a blueprint made from it. It does not, however, have the ability to be dragged into a level, as we've seen. Now, you have a class derived from object, a child class called actor. We say that an actor is an object because it is derived from that class. So it inherits the qualities of being able to store data and being able to be made into a blueprint from its parent class, object. But the actor also has new, unique capabilities of its own that its parent class does not have, such as the ability to be placed or spawned in a level, among other capabilities. With inheritance, we are speaking of the is-a relationship. An actor is an object, but not all objects are actors necessarily. So this relationship doesn't go both ways, just like with the animal analogy. So we've seen the is-a relationship. This is when a class is the child of another class. We use the terms child class and derived class to mean the same thing. We also say that the child class is based on or derived from the parent class. You'll hear these words base class and parent class used interchangeably. These are all terms for the same concepts. Now let's talk about has-a relationships. We know that our actors can have components. We say that an actor has a component and there is no inheritance going on with this relationship. When we add a component to an actor class, we are simply making use of a concept called composition, where we extend our actor's capabilities by composing it with additional subobjects. These are the components. This is the has-a relationship. An actor has components, but the components are not actors and they're not children of the actor class. So we have two ways to extend the capabilities of any given class. One is through inheritance, by deriving a new class from an existing parent class and inheriting properties from it. And another is through composition, adding subclasses for our class to have. These are the is-a and has-a relationships in programming. More specifically, these are concepts related to object-oriented programming, OOP for short, and they're important to understand because the blueprint system is object-oriented. Now, pawn is derived from actor, so it inherits the ability to be placed in the world or spawned in. But it also comes with more capabilities, such as being able to be possessed. This means we can assign user input, such as mouse clicks and keyboard presses, to control a pawn. This is why we were able to fly around in our game project, because the default pawn is automatically spawned in and we automatically possess it with some default input behavior. WASD input allows us to move the default pawn. In Unreal Engine games where we plan on using input to move an object directly like this, we make use of the pawn class, and we set up inputs so we can move that pawn and its movement is tied directly to our input. Those key presses, moving the mouse, and so on. This is different than the movement we've done so far on actors, where our movement was the result of logic in the event graph. This section is all about creating a new custom pawn, so we don't have to just use that boring default pawn. We'll also learn about how to set up inputs so we can press keys and move our mouse to move our own custom pawn class. We'll do this by using Unreal Engine's enhanced input system. So let's get started making our very own blueprint class based on pawn.